So we are going to be working on Module 2, Lesson 1 today. And in the beginning of class, we had a discussion about the similarities and differences between positive and negative numbers. You can see some of the things we have come up with, how negative numbers are to the left of 0, positive numbers are to the right. We have that negative numbers are opposites of positive numbers. Positive numbers are opposite of negative numbers. Negatives mean that you lose yards, you lose money. It's a loss, a drop, or a decrease. Whereas positive numbers mean gain or increase. Now, both of them are on number lines, so that goes in the center of our diagram. They can have different looks. Usually negatives are written with negative signs. Positives usually don't have a sign. So these are just some of the similarities and differences we came up with in class. I'd like you to pause the video so that you can copy down all of these different statements into your diagram. All right, so we're going to be talking about counting up and counting down on a number line. Now, counting up, starting at 0, corresponds to all positive numbers. So when you count up, you're going in the positive direction, always starting at 0. And counting down, starting at 0, corresponds to negative. So if you're counting down, you're going, that's associated with negative numbers. Now, let me show you how this works. So if we want to count up 7, we would start at 0, and we would count up 7 spots. So 2, 3, 4, 5, 6, 7. So that would be 7 units to the right. That's positive 7. Now, if you want to go negative 7, you would be counting down from 0, 7 units. 5, 6, 7. Now, negative 7 is 7 units to the left. Now, we can even talk about these arrows are pointing in different directions, but they are the same lengths. We call that absolute value. So we could say the absolute value of 7, remember that's the distance from 0, is still 7. But the absolute value of negative 7 is also 7. It still has a length of 7, just in a different direction. Now, where did you begin when locating the numbers on the number line? And I mentioned this earlier, we're always starting at 0. What do you call the distance between the number 0 on a number line? Remember, we just talked about how the distance is called absolute value. That's how long your arrows will be. Now, what's the relationship between 7 and negative 7? Well, we just took a look up here. 7 and negative 7 are the same lengths, but they are in different directions. So the absolute values are the same, but opposite directions. All right, so next page. All right, example 3. We're going to use this thing called the integer game a lot throughout this module. The integer game has cards, and you're going to have a series of cards in your hands. This is the values on the cards we have right now. And we're going to use the counting method to find the sum of the card. Now, remember, sum means that you're adding them all together. So remember, we just talked about starting at 0. So our first number is 5. It's a positive 5, so we're going to go 5 units to the right. Okay, so that would be plus 5. Now our second card is negative 5. So you're going to start where you left off, and you're going to go negative direction, which is to the left, 5 spots. That would be -5. Now we have -4, which we're going to go from where we left off, which would be at 0. And we're going to go negative direction 4 spots. And from there, we're going to go to 8, which is in the positive direction, and we're going to do that 8 spots. Now, wherever you end, it would be your sum. So we started at 0, we counted up to 5, we counted back 5, we counted down 4, and we counted up 8, which left us at 4. So the final position on the number line is 4. Now, what card or combination of cards would you need to get back to 0? So if you're at 4, what card would we need to add to our pile to get us back to 0? Well, going to the left means we're going to need a negative. And we're going back 4 spots. So that would be -4. Now it says combination of cards. So this is if we were picking one card. If we wanted to pick more than one card, we could go back 1 spot and then go back 3 more. So you could get -1 and -3. You could do -2, -2. That would also get you back to 0. All right, so let's do this again. We're going to use this number line to answer the following question. So how far is 7 from 0 and in what direction? So here's 0, here's our starting spot. So 7 is 7 units away. And it says in what direction. Now we're going to change, instead of doing each little loop individually, I'm just going to take one loop all the way over. Even better yet, you know what? I think I'm going to even make it a straight line. That way we don't even have to, we can put it all on top of one another. So 7 units would be to the right because it is a positive number. All right, what is the opposite of 7? Remember, opposite means it's the other direction. So in this case, it would be -7. So how far away is -7 from 0? Well, it's still 7 units away, but this time it's to the left. I'm going to use the straight arrow again. 7 units would be -7. All right, thinking back to our previous work, let's explain how you could use the counting on method to represent the following. So we're going to play the integer game again. The first card is a 7. The second card is a -7. So let's describe the process. We are always going to start at 0 when you're counting. The first card is a +7, so we're going to count up 7. And remember, counting up means you're going to the right. The second card is a -7, so that means we're going to count down 7, which means we're going to the left. And Party says, what does that tell you about this sum? So you start at 0, you count up 7, down 7. Where does that leave you? Well, that leaves us at 0, which means the sum is going to be 0. If you want to write a number sentence, a number sentence would be 7, the first number, plus -7 equals 0. We know that our sum is 0, so that equals 0. All right, so let's look at the curved arrows you drew. I told you I changed them to straight arrows for 7 and -7. What relationship exists between the two arrows that would support your claim about the sum 7 and -7? So the relationship would be that both arrows are the same distance from 0, but pointing in the opposite direction. So do you think this will hold true for the sum of any number and its opposite? Think about that. If you're always starting at 0 and you move up a certain number and back down that same number, you will always end up at 0. So it would hold true for any number that you choose. Even if you choose the negative first, if you went down by 10 and back up by 10, you would still end at 0. So this whole idea of going up and down the same amount of times is called the additive inverse of a number. So additive inverses will always add up to 0. So 3 and negative 3, 2 and negative 2, those are additive inverse. So the additive inverse of negative 3 is 3. All right, example 4. How would the value of negative 10 represent a temperature? Now we're talking about real world things. Like if I want to apply this in the real world, how would negative 10 represent a temperature? Well, negative 10 would be 10 degrees below 0. How would the temperature need to change in order to get back to 0? So let's take this whole idea of additive inverse. If you've gone down to 10 degrees, you need to go up 10 degrees, or we call that a rise of 10 degrees. Now, I want you to, on your own, write a story problem using money that represents this statement right here. So it's going to be a real-life application that's going to represent a positive and a negative going back to 0. You're talking about money, so go ahead and pause the video and come up with a story that represents this expression. Now, that is all we have for lesson 1. Your problem set is on the pages following.